Okay, I am recording this session so that if there are students that weren't able to make it for scheduling reasons or whatever, that they do have access to the video of this session. And in this session, according to your instructors, this midterm is going to cover chapter 1 and chapter 2 from your textbook. Now, it's important to realize that these algebra toolbox modules, while they're not going to test over those explicitly, it's expected that you understand the material in those toolboxes. And so if you're struggling with any of those foundational concepts, it's a good time to go ahead and get those figured out so that they're not messing up the current concepts. So accordingly, I'm going to focus on these 8 sections this evening. And then time permitting, we can go back and hit concepts from the algebra toolbox if we need to. All right, so the way I like to arrange these review sessions are to use student learning outcomes, or sometimes they're called SLOs. Student learning outcomes are really handy because they're really setting the expectations for how deeply you need to understand the material. So it could be something as simple as, hey, do you remember the equation for the slope of a line using slope-intercept form? Something like that. It could be, can you write this function as a composition of another function? Okay, so that's the 112B review that I'm doing tomorrow night. And as you go up this Bloom's taxonomic pyramid, you see that the tasks get a little bit more challenging to accomplish. And so when you're looking at these learning outcomes, the heart of the matter is right here. I want you to use those student learning outcomes and turn them into questions. So look at that student learning outcome and ask yourself, first of all, do I recognize all the terms in this question? If it sounds like they're speaking Greek to you, well, then you need to go back and make a list of definitions. I know, especially for me, going back and brushing up on this material so that I could work with math students, I was like, oh gosh, asymptotic means, yeah, there's cobwebs back there. I think I can blow them away and we can get through this. The second step, do I understand what the question is asking me to do? If not, see if you can break it down into individual pieces until you understand, okay, it's asking me to do this. All right. Next, can I find examples of questions that match this learning outcome? All right. I have done this for you in this review packet. I'm really hoping to model the behavior I want to see when you're studying for math classes and especially for your math exams. All right, so you'll see that I've got a learning outcome. I've grabbed some of the notes out of the textbook. So they've got these little highlighted box with extra information. So I've used those underneath the learning outcomes. And then I found examples of questions. And then next, can you answer the question? And once you got an answer, can you look at that answer and say, okay, does that make sense? Is this reasonable? And if not, then can you figure out how to check your work to make sure it is the correct answer? Okay, so if you answer no to any of these questions, that's where you start focusing your efforts. Okay, so if you get stuck at 2, you do not pass go until you get 2 figured out. All right. All right, so those are our student learning outcomes. Now, in chapter 1, we begin our discussion of functions, graphs, and models, and also linear functions. And so you can see this chapter 1 algebra toolbox. I've got learning outcomes. So this is the learning outcome right here. Write sets of numbers and identify elements, subsets, intersections, and unions of sets. And then anytime I've found a relevant note, I've added it underneath that learning outcome. And then these are example problems from the textbook. And so that tells us that if we are looking at the odd answers or the odd questions, we're going to find those answers in the back of the textbook. So feel free to practice on these. I literally just pulled all these learning outcomes out of your supplementary My Math Lab materials and out of your textbook. All right, so we're not going to do the algebra toolbox because that's not what we're testing over. You can see I've got a lot of good notes in here. I hope you find them helpful. We are going to go ahead and start with functions and models. So for our first learning outcome, we're asked to determine inputs and outputs of functions and evaluate a function using function notation. All right, so questions 2, 4, 6, and 8. Are there any there that you'd like to see worked?
Yeah, I would like to see number 8 and number 2. Number 2 and number 8.
2 and 8. Okay, 2 is popular. We hit that every single time I do one of these review sessions. Okay, so number 2, table B gives y as a function of x with y equals g of x. So they're using that function notation. And it's important to realize that whenever you're working with this type of information, x is going to be our independent variable and y is going to equal our dependent variable. So y depends on the value of x. So for that reason, because x is an independent variable, you can think of that as the input, and you can think of, well, y is a function of x, so this is going to be an output. All right. So from there, they're asking, is 0 an input or an output of this function? And we see that the only place we have a 0 is in the x. And so that's going to make that 0 an input. So we're going to put 0 into the equation. And when we put 0 into the equation, our output is 3. And then is g of 7 an input or an output? Well, they're saying g of something, okay? And that's the first clue that this is actually an output, all right? So g of 7, let's see, g of 7, y equals g of 7. And we know that that 7 is representing x. So where x is equal to 7, all right, we see that the answer to y equals g of 7 is 9. So g of 7 is going to be the output, and the output is 9. Does that make sense?
Yes, that makes perfect sense.
Awesome, cool. And then when we're talking about the domain and range, okay, the domain is going to be all of the x values, and the range is going to be all the y values. And when you have this set of ordered pairs, you have to list the domain values and the range values in set notation. I think it's set notation is what they call it. So here we would say the domain, and we use these little curly bars, is going to be -4, -1, 0. So I'm literally just copying these values down here. So -4, -1, 0, 1, 3, 7, and 12. And then if we want the range, that'll be the y values. And the y values, they aren't quite in order, but we can look at them, skim through them right quick and see that 3, 5, 7, 8, 9, 10, and 15 are what they're looking for. All right. And then explain why this relationship describes y as a function of x, okay? And so this is part C. And then part D, why this relationship describes y as a function of x. Well, y is equal to g of x. That's our function notation. But then also we see that for every x input, it's going to map to 1 y output. Okay. And so when we're talking about whether something is a function or not, they use this little mapping notation. And we see that as long as we have one input going to one output, that's defined as a function. Okay, and so we could literally say, all right, well, here's my domain. My domain is -4, -1, 0. Okay, and that's just part of it. And then my range is 5, 7, 3. And then we see that this function maps 4 to 5. So 1 input to 1 output, -1 to 7, and 0 to 3. The only time it's not a function is when you have one input or X value and it maps to or leads to 2 outputs. All right. And so if we wanted to break our function, we could say, oh, well, if 0 equals 3, 0 input gives us 3 for an output, but also 0 maps to 7, okay, that would break this. This would make it not a function. So 0 going to 3 and 7 equals not a function. All right. Does all that make sense?
Yes, perfect. Thank you.
Wonderful. So glad. All right. Now, question 8, for each of the functions y equals f of x described below, find f of -1. So f of -1, they told us right here that whatever this number is, that's x. So you want to find where x equals -1 and see what y value results. All right. So if we look at this scatter plot, man, that is an ugly scatter plot. I'm having trouble reading this because it's got like -6.6 to 5.6. Okay. And 8.2 to -4.1. All right. So if we're looking for x equals -1 is not even on this graph.
No, it's not. You're right.
Not the way they got it. Wait. 5.6, 6.6. Okay, wait a second. If this is 5.6, that is just rough. You would find where x equals -1 and you would just indicate what y value that is. Let's not worry about something that's not a great option there. So yeah, we would have a much cleaner graph if it was on the exam. If we go to part B, x equals -1. When x equals -1, we see that the output is -8. And then if we were to do this for part C just means that we would say f of -1, and we would plug in -1 everywhere we see an x, and then we would evaluate the results. And so f of -1 would be equal to -1 times -1, which gives us a +1. +3 times -1 gives us a -3. And then we're going to add 8. So 1 minus 3 plus 8. So we're going to get f of -1 is equal to 6. All right. Did that make sense?
Yes, it did. But I do have
Okay.
a question.
Sure.
For A, just for argument's sake, if it were, graphed correctly, what would that look like when you would answer the question?
Okay, so what that would look like. So suppose that, let's just grab this and say, I'm wondering if this is graphed so that x equals -1 is the origin. If that was the case, if this was x equals -1 here, then you would track up until you see the value for y, and we see the value for y would intersect right there. And so this would be at x equals -1 and y would be a +1. That would be the best way to attack that problem.
Gotcha. So we'll be looking for an ordered pair.
Yes, yes.
Okay.
Essentially, these are all ordered pairs. All right. So that's page 8. Let's look at our next page, and I will send out this video and all my chicken scratch to you guys afterwards, okay? All right, so let's see. We've got question 62 is still in that same learning outcome. And then we also have questions 14 through 16 in the next learning outcome, determining if a table, graph, or equation defines a function. Do we need to see any of those?
No, I'm good on that one.
Okay, awesome. All right, Savannah, if you need any of these, feel free to drop it in the chat or just unmute yourself. Okay, how about finding the domains and ranges of functions?
Yes, I could stand to learn some more about that.
Okay, love it. All right, so when we have a scatter plot, such as in number 26, with a scatter plot, then we have to list the domain and do so by grabbing each of these pairs. And so we've got 1, 2, 3, 4, 5, 6 values to report on. And so with the domain being the set of all X values, I'll put my curly bracket there, and I'm going to say, okay, knowing that this is X and this is Y, I see my smallest value of X is number 6. I also have -4. I have -2. I've got one on the axis, which gives me a value of 0 for X. I've got one at X equal 2. And I'm just reading these left to right. And then another one at 4. All right. And then if I'm looking at the range are going to be all the Y values. And so for the Y values, I'm going to read from the bottom up. And so here I've got, if this was -6 for the X, I would call this -5 for the Y. And then the next one I have is at -2. I've got one right here on the axis, and that's going to be at Y equals 0. I've got Y equal 1, Y equal 4, and Y equal 6. All right, so those are kind of a pain because you have to list every single value. Now, when you have something like 28, where we've got this continuous smooth curve, that simplifies the work a little bit because we're looking for the maximum and the minimum on both the X and the Y axes. So if we look at X, we see the smallest value of X, all right? And there's 2 ways we can write this. So we can say the smallest value of X is -4. And then because this dot is filled in, that filled in dot says that we have to use a bracket to show that the function is valid at X equal -4. And then if we trace the curve and we find the maximum value of X, we see that occurs at X equals 3. And again, that's a filled in dot, so we would use the bracket. Okay, so we could use the bracket notation, or we could also say -4 is less than or equal to X is less than or equal to 3. Either way of describing the domain should be counted as correct, unless your instructor is saying use inequalities strictly or use set notation. If we look at the range for 28, okay, the range is going to be the lowest value of Y. So I've got the low value down here at -1. And I see my maximum value of Y is going to occur at Y equal 4. And so again, this is on a continuous curve. There's no open spot there. So we know that the function is valid at each of those locations. So we would say the range is -1 all the way up to 4. Or we would say -1 is less than or equal to X is less than or equal, I'm sorry, Y is less than or equal to 4. Does that help?
That does help, but my question would be in the range, You did brackets again and not parentheses?
That's correct, because those are solid dots. Now, if we had found a situation, like suppose this continued on and it ended like that, that open dot would say that instead of using a bracket, you would have to change that to a parenthesis because it's valid up to, but not including that point.
I got it. I assumed that the brackets were only for the domain and that the range would have something else. That's where I got stuck. Okay.
Yeah, I can see why. Yep.
Yeah.
All right. So that's page 10. Let's see what we got on the next page. And so we've got question 47 that deals with that same, find the domain and range of functions. This time they're just giving you a data table. It's much the same process. And then the next learning outcome. Okay, Savannah wants number 47, part 1. Absolutely. Okay, so if we're doing 47, part 1, does the table define weight as a function of the day in May? Okay, if we look at this, to have a function, okay, to have a function, we need to see one input going to one output. Whoops. Okay, and so we can also have, let's see, we can also have one input or multiple inputs. So multiple X values going to one output. Okay, so that's a function, not a function. Means that we've got one input going to two outputs. So for example, if we had a domain and a range, these little maps kind of help demonstrate this. All right, so if we had 4, 8, and 13, and our outputs were 7, 6, 8, and 9. Okay, so this is input for our X value. This is our output for our Y value. All right, suppose that we have 4 mapping to 7. So this is our f of X, this is our function. And if 8 is mapping to 6, that's our function still working. And 13 maps to 8. But then we go back and find, oh, well, there's a special case where 8 can also map to 9. Okay, if we have one input mapping to 2 outputs, that makes it not a function. So that's what we're looking for with this data set. And so with this data set, we see that it's okay if multiple inputs go to one output. And so 1 goes to 178, 2 goes to 177. We see that for each day, okay, so the days are the input, each input maps exactly to one output. And so that means that, yes, this is a function. All right, does that make sense?
Yes, that does make sense. But
Awesome.
isn't there a rule about having 2 outputs being the same?
It makes it not a function. And you see that because whenever you've got one input making 2 outputs, what happens is if you've got one X value and that X value maps to a point here and a point there, okay, closed in dots, that would fail our vertical line test because you can't have one X value mapping to 2 different Y values. So yet another way to look at it.
Right. So is it a function or is it not a function?
This is not a function.
That is not a function.
Yeah, all of this down here is showing what it means to not be a function.
Okay.
And let's see. If we actually go back to this page, the vertical line test, we see that number 15 is not a function. And that's because for one X value, so one input, it's going to map to two outputs. It maps to here and here. So this is my input and here are my outputs. Does that help?
Yes, yes, it does.
Awesome. Awesome. Great. All right. So let's see. How about converting given steps and verbal descriptions of functions into equations? Do we need to see 35, 38? Those are the only two I've got there. Or do we want to move on?
Let's keep it moving.
All right, next page. Solve applications involving functions and models. That would be question 46. Or answer questions involving finding function values, question 54. And also question 58 on the next page.
Let's do them.
Okay, do them all?
Yes.
Okay, bring it. Okay, so if we want to solve an application involving functions and models, okay, our first one is on seawater pressure. And here they have, instead of X and Y, they've thrown us some P's and some D's. All right, so in seawater, the pressure P is related to the depth D. All right, and so P related to D tells me that P is the output and it's described in terms of D. Okay, so D is the input or the independent variable. Okay, so in seawater, the pressure P is related to the depth D according to this model, where D is the depth in feet and P is in pounds per square inch. Is P a function of D? Okay, I would have to say yes. Yes, this is a function. P is a function of D. So we could say P is a function of D. And we can say that because for every unique depth, we're going to get one pressure reading. So it goes back to those domain and range maps like I drew out, where I was showing one input going to one output, two inputs going to one output, but never one input going to two outputs. All right. We look at 54, population of females under 18. We have a graph and it's in thousands projected from 2020 to 2060. And it's a function of F over the year T. Okay, so the year T, this is our input. And we see that this is independent. And then our, let's see, our function over here, this is our output. And what is the function, or what is the output of F of 2030? So for F of 2030, we're going to go down here and find 2030. And we could say that when T is equal to 2030, we see that we're going to have 39,000, I think that's 39,244 females. Okay, so interpret that result. That means in the year 2030, we're going to have 39,244 females under the age of 18. And then is this function increasing or decreasing? If we were to connect the tops of these peaks, just roughly, we see that the slope is positive. Okay, if we were hiking up this, we'd need our hiking boots because that positive slope means we're going to have to work hard because it's increasing. All right, questions over those two?
I didn't quite get how you figured the first one.
This one, 46?
Yeah.
Okay.
Yeah.
All right.
Like you got all that from that equation?
Yeah, let me slow down and back up on that one. All right, so if I were to make a table of values just to kind of see how this works, I could say, all right, the depth D, okay, depth is in feet, so D is in feet. And whenever I pick a value for D, that's going to give me an output of P, and that's going to be the pressure in pounds per square inch. And so I could pick D equal to 10. Let's do 10, 20, 50, 100. And we see that we have to plug that into the equation. So the fact that we have the leisure to pick what we want for a depth to figure out what the pressure is tells us P depends on D. And so if we say P is equal to, and we see the function is 18 times D plus 496 over 33, we see that, yes, Savannah, y equals x is a function. Okay. And then we see that we get 180. So 18 times 10 plus 496 gives us 676 divided by 33. We get 20.48. And so we could keep going down the line and doing that. If we did 18 times 20. So if we figured out 18 times 20 plus 496 divided by 33, we get 25.94. And we could just keep going down the line. And we would see that for every one input, we're getting one output. Savannah, you're funny.
Got it. Makes sense now.
Okay, awesome. So yeah, y equals x is a function, Savannah, but not xy equals 1. We'll save that conversation for another day. Okay, and then 58. If we look at 58, this one is talking about Social Security funding, and it's funded by people that are currently employed. So this graph shows that the number of workers in, so a lot of times I will go through and highlight what's important so I can ignore all the rest of the words because sometimes there's just too many words. Supporting each retiree as a function of time t, okay? Denote this function by n equals f of t. Okay, so what all of that is saying is that down here is the year. This is our t. This is our independent variable. And this is going to be our input. So this is the number we're manipulating. We're going to slide the scale back and forth between 1950 and 2050. And then we're going to look at what output results. So if we find f of 1990, all right, f of 1990 means that we're going to come right up here and we see that they've marked that value. And we see that f of 1990 equals 3.4. Okay. Now, according to the question, n equals f of t. So this equals n, where n is the number of workers supporting each retiree. So we see in 1990 that Social Security wasn't in quite as much trouble as it is now, because for every one person that was retired and drawing benefits, we had 3.4 people in the labor force supporting their retirement. If we look at B, in what year will the number of workers supporting each retiree equal 2? That's telling us to look at the output. And just squinting at this graph, I would say that probably 2030 is the best option there because it's right at 2. All right, so T equals 2030. And what does this function tell us about Social Security in the future? Well, the graph is decreasing, and we see that going from 1990 to 2030, we're going from 3.4 workers down to 2 workers supporting every individual retiree. So this tells us that Social Security in the future is in trouble as far as funding is concerned. So it's time to make a backup plan.
Well, at least it's accurate.
Right. All right. Did all that make sense?
Yes, it did.
Okay, awesome. All right, so the next learning outcome, answer questions involving domain and range. Do we want to see 52?
I'm good on domain and range.
Okay, wonderful. All right, so then this brings us to our second section, graphs of functions. And it's going to ask you to graph equations quite a few times and to create tables of values. If you're graphing equations and you're always going to start by creating a table of values, kind of like I did for the PD problem. What values do I want for depth? What output results for the pressure when I do that? And then you also need to be able to graph this on your calculator. Graphing it on your calculator is outside of my area of expertise, so I'd encourage you to talk to your instructor, your course embedded consultant, or anyone else involved in teaching your class that is current on how to use this generation of calculators. So for graphing and creating a table of values, do we need to see any of that worked out?
No, I'm good.
Okay, good. Graphing scatter plots, more of the same. If you want me to go back and hit any of those, let me know. I got a note from Savannah. More scatter plots on page 17. Okay. And then when we get to page 18, we're going to start solving applications involving graphs of functions. Do we need to see any of those?
Yes, I do.
Okay, what would you like to see?
32 and 35. 35. What is that? 30.
32 and 35.
And 45. Why is it
Okay.
45 in between the
Yep.
two of them?
Yep. Okay. Yeah, 45 and 35 are popular at every review session, so good choice. Okay, so suppose f of x equals 100x squared minus 5x 1,000 units are produced, where x is the number of years after 2000. So what is f of 10? All right, so for this one, f of 10 means that we're going to take our equation f of x, and everywhere we see an x, we're going to go ahead and just plug in a 10. So it'd be 100 times 10 squared minus 5 times 10. And that'll give us a big number. We're going to minus 50. So that'll give us 9950. All right. How many units are produced in 2010 according to this function? Okay, so number of years after 2000, if we're looking for number of years after 2000, well, then we need to use x equals 10. And that's what we just did in the previous part. So f of 10 gives us this 9950, where x is f of x is thousands of units. So we need to turn this into a 1,000 because f of x is defined as 1,000 units. Does that make sense?
Yep.
Groovy. All right, so 45, student loans. Data for selected years from 2011 and projected to 2023 can be used to show that the balance of federal direct student loans y in billions of dollars, ouch, is related to the number of years after 2010, x, by the function y equals 130.7x plus 699.7. Okay, so we would graph the function for x values corresponding 2010 to 2025. Okay, and so if we were graphing this, we would go say, so 5, 10, 2010. Okay, so 2010 would be x equal to 0, and 2025 would be, let's see, years after 2010. So this would be 2010. This would correspond to 2015. This would correspond to 2020. And we'd have to go out just a little bit further to get to 1, 2, 3, 4, 5. There we go, 2025. All right, so we would graph that by plugging in our x values. And once we plugged in the x values, that would kick out a certain value for y, and we would plot that. And then find the value of y when x is 13. So y equals 130.7 times 13 plus 699.7. So you just plug in x equals 13 and solve for y. And then using that information, you could predict the balance of federal direct student loans in 2029. And the way you could do that, and this bears a second of time here. So if we look at the year 2029, and our x is years after 2010, so we're going to subtract 2010 from this. And so we see that x would be equal to 19. And so if we take that x equals 19 and plug it into the function, so 130.7 times 19 plus 699.7, that would kick out that value requested in part C. Does that make sense?
It does now.
Brilliant. Good, good, good. All right. Height of a ball. If a ball is thrown into the air at 64 feet per second from the top of a 100-foot tall building, its height can be modeled by the function. Okay, so the only thing we really need so far is S equals 100 plus 64t minus 16t squared. So they figured out all the yucky physics for us, and we're just going to take their result and run with it. All right, so S is in feet and T is in seconds. Graph this function for T representing 0 to 6 seconds and S representing 0 to 200 feet. So this is just setting your graphic area. Find the height of the ball 1 second after it is thrown and 3 seconds after it is thrown. Okay, so for that one, you would set S equal to 100 plus 64 times 1 minus 16 times 1 squared. And so this is the height at 1 second. And then this is also the height at 3 seconds. Whoops, 3. And this is going to come out to the same answer. And that makes sense if you stop and think about the context of what's going on there, because if we're standing on a building and we throw a ball up in the air, okay, at some point it's going to be here, but then it's going to be right here again. All right, what goes up must come down. All right, and then find the maximum height the ball will reach. Okay, so the height, S is in feet. Let's see, we would want to find the 0 of that. So we know it's going to be somewhere between 1 and 3 seconds. So we could probably go ahead and use t equal 2 seconds to find that information, just because we know it's gone up and come down in the space of 3 seconds. Otherwise, we've got some other techniques a little bit later in this packet we could use, finding the maximum and minimum of parabolas. But I think using part B as our clue and then going from there is the best bet. All right, questions on those?
Nope.
Awesome. All right, linear functions. So we know a linear function is going to be a function where x is to the first and y is to the first. All right, so this x to the -1 is not a function, and x squared is not a linear function, and x squared is not going to be linear. So we see a linear function has to fit this format, f of x equals ax plus b. If it's anything else, not linear. All right, how about finding slopes and intercepts? Good on that? Oh, no worries. Feel free to head out whenever.
Yes, I'm good on that. I think these I've been using the calculator to do a lot.
Yeah.
Finding the intercepts.
Yeah. Well, since you have to leave in 9 minutes, are there any other questions in this packet that you'd like to see worked? You could tell me a page number and we can go from there.
I scanned through it earlier. So I don't even know what's on the other pages. I'm sure there's stuff on there I need to learn.
Yeah.
But I'll just, you feel free. I'm learning everything you're teaching. So this is all good for me.
All right, awesome. Because I can, let's see. So on page 29, the difference quotient, that's a popular question. Every time I do one of these review sessions, I'm taking notes on what's tripping students up. And then 2.3 and 2.4, solving linear equations. That was also a pretty weighty topic for everybody. So let's go to page 29. All right, so this piece, do you remember how to do the difference quotient? Would you like to see that right quick?
Absolutely.
Okay, fantastic. And so this difference quotient means that we're going to take an f of x value, and then we're going to also use f of x plus h. All right, so the way this works, the difference quotient tells us that we want f of x plus h minus f of x. We're going to divide that by h. And so the easiest way I have found to accomplish this is to figure out what each of these pieces are and then plug them in individually. So this f of x plus h means that we're going to take our original f of x function, so 45 minus 15, and then instead of saying times x, we're going to say times x plus h. And so this f of x plus h will give us 45 minus, we got to distribute -15 to x and -15 to h. All right. Now, none of those are like terms because they've got no variable, x variable, h variable. So that's f of x plus h. So then if we put it together in this difference quotient, we're going to get f of x plus h. So 45 minus 15x minus 15h. Subtract from that f of x. Our original f of x from question 33 is 45 minus 15x. Then we're going to divide all this by h. So when we distribute that negative, we get 45 minus 15x minus 15h. -1 times positive 45 gives us -45, and -1 times -15x gives us positive 15x. This is still all over h. And then combining like terms, we see positive 45 and -45 cancel out. negative 15 and positive 15 cancel out. We're left with just negative 15h over h. And so the answer for that one is negative 15. Does that help?
Yes, that did tremendously.
Okay, fabulous. And then let's see, popping over to chapter 2. Let's see. Let's see, on page 47, solving by substitution. There it is. Number 19 has been really popular. We can solve by substitution. We can solve by elimination. This one was tripping students up just because it's pretty involved. And so if we take 19 and we look at it, if we want to solve by elimination, we want to look for the terms that have a positive and a negative in front of them. If we can multiply the smaller number by some constant so that the size of these is the same, then we can get these, we can add these two equations together and get them to cancel out. So in practice, what that looks like, we want negative 3y to cancel with positive 0.4y, but we've got to multiply 0.4 by something to get it equal to 3. And so the best way to figure that out is to just say, all right, what is 3 divided by 0.4? And we see it's 7.5. So we're going to use this to multiply the top equation. So when we do that, we're going to say 0.3x plus 0.4y equals 2.4. We're going to multiply that by 7.5. All right, dropping that in my calculator, I'm going to get 0.3 times 7.5 gives me 2.25x plus, we know 0.4 times 7.5 gives us 3y equals, and then 2.4 times 7.5 gives us 18. All right. Now I'm going to add to that my second equation where I see that 5x minus 3y equals 11. And my 3y's are going to cancel out. I'm going to get 7.7 or 7.25 x is equal to 7. And so x is going to be equal to 7 divided by 7.25. 0.965. So not a pretty number, but kind of to be expected because we had decimals. And then we can plug that into either of these equations to solve for what the value of y is. So we can say 5 times 0.965 minus 3y equals 11, and then we'd solve for y.
Excuse me, Lisa.
Yes.
I was taught to change those decimals to whole numbers first. Is that not?
Oh, that's totally fine. Absolutely. Okay. Because what you're doing essentially is multiplying by 10 first, and you're going to get the same answer. As long as you do, okay. Yeah, as long as you treat both sides of that equation the same, it's going to work.
Copy that.
Good point. All right. Anything else I can help you with before you drop off tonight, Mark?
Just keep going so that I can look at the recording later.
All right. So we're gonna have to rely on Savannah to ask more questions for the next 30 minutes.
Oh, great. Come on, Sam. You can do it. All right. Thank you so much.
Sure thing. I'll email this to you after it's done. Okay.
Awesome.
Fantastic. Okay. So Savannah, I see you wanted to ask about the difference quotient. Do you have other questions right off the top of your head that you want to see worked?
Not really. I think like difference quotient is one that I really know I struggle with, and substitution and elimination. Both I need work on.
Okay. Let's see. Do you want to do, let's see. I've got a substitution problem right up here we could work through.
Okay.
All right, let me drop a little sticky note here so we got some room to
Oh.
work.
That's why I had it muted. My dog is
Your dog is totally welcome. If I
every
was
time
gonna-
she hears something outside or a squeak or anything, she barks, and she always ruins my Zooms.
I feel you there. Okay, so out of questions 11, 12, 13, and 14, is there one of those that looks particularly scary that you'd like worked?
Let me see. Yeah, could we try 14? That one probably looks the hardest.
Yeah. Okay. So 4x minus 5y equals negative 17, and 3x plus 2y equals negative 7. Yeah, those are going, that's yucky. You chose well.
Yeah, I like looking at this one. I have no clue where to start.
All right, let's just take the first equation, 4x minus 5y equals negative 17. And let's solve for x so that we can plug that into the other equation and see what we get.
Okay.
If we isolate 4x by adding 5y to both sides, we get 5y minus 17. And we could have written it as negative 17 plus 5y. I just like to throw that negative in between things to make it more prominent. And then we divide both sides by 4. So we get x is equal to 5/4 y minus 17/4. Yeah, that's gross. Good job.
I know. Yeah, it didn't look very good to me.
3x plus 2y equals negative 7. We're going to take this value for x and plug it in there. And so everywhere we see an x, we're going to put in 5/4 y minus 17/4 plus 2y equals negative 7. All right, so we've got to distribute that 3 to everything inside the parentheses. So 3 times 5/4, I'm going to just keep that 15/4 y. 3 times 17 is too big for this hour of the day. 51 plus 2y equals negative 7. Okay. So let's see, 15/4 y and 2y, I can combine those terms. And so I'm going to call this 15/4 y plus, and if we turn 2y into fourths, we're going to turn this into 8/4 y.
Okay.
And then we're going to subtract 51/4. That's equal to, if we do 7 into fourths, 7 times 4 gives us negative 28/4. Okay, so 15 plus 8 gives us 23/4 y. And then I'm going to add 51/4 to both sides. So 51.
Before I do this step, I just wanted to ask, can you go ahead and like multiply everything by 4 to get rid of that, all of the fractions? Okay.
Absolutely.
Because I just hate that, and it really confuses me when I see them. So I like to get rid of them. And I was just wondering if that's right. Okay.
Yeah. You want to back up and do that before we keep going?
Sure.
I
I like
like
to, Professor Johnston calls it hit the easy button. I like
Love
to hit the easy button.
it. All right. So yeah, let's see. Let's back up all the way to right here. So let's also multiply the whole thing by 4.
Oh, okay. All the way up there. Okay. See, like,
Yeah.
I didn't know I could do it that far back.
Yep. As soon as you see a nasty fraction show up, oh yeah.
And then it can get rid of all that. Okay.
Yeah. And so if we do that, we wind up with 4 times 3 is going to give us 12. Okay. And this will This will get rid of those fourths in a second. Plus 2y times 4 gives us 8y is negative 28. Okay. So then we know that 12 over 1 times 5 over 4y, that is going to give us 15y. And then 12 over 1 times 17 fourths is going to give us 51. Okay, so this is our little side note. And so this becomes 15y minus 51 plus 8y equals negative 28. Did that make sense, or did I lose
Yeah.
you? Okay,
And so
awesome.
is that the final answer?
Nope. Now we got to
No.
combine like terms.
Okay, okay.
So we've got 15y and 8y, which are common because they both have that variable y.
Right.
So this will be 23y. And then I'm going to add 51 to both sides. And so I'm going to get 51 and I'm going to take away 28. So that's going to give me, oh, look how pretty that's going to work out. Who'd have thought? Okay, so we've got
Okay,
y.
yeah, that was horrible to get that. It looked so awful at first. That looks a lot better.
And then now that we've got y equals 1, we got to plug it back into this one
To get, okay.
to get x. Yeah. And so we could say 4x minus 5 times 1 equals negative 17. So 4x minus 5 equals negative 17. Add 5 to both sides. I'm going to get 4x equals 12. X is going to be equal to 3. All right. So the answer for 14 is going to be 3, 1.
Okay.
I feel
Yeah.
very accomplished now. How about you?
I do too. That I feel a lot more prepared for tomorrow after that one.
Awesome. I am so glad to hear that. All right. We've got another 23 minutes together. What else would you like to see worked?
Okay, can we do another of the difference quotient?
Yeah,
It went pretty
absolutely.
fast and
Yep.
I really struggle on those. I can't remember.
Yeah, I understand. I had to go back and make sure I really understood how to talk about it tonight before I got online.
It's
It's
so
the-
hard to remember all the rules when you don't use them all the time.
Exactly.
I just started school back after being out of school for 4 years, and trying to remember all the math rules is like,
Mhm.
it's impossible.
It's a steep learning curve, but man, the more you practice problems, the more it's going to enforce those rules, and it
And-
will get easier.
Yeah, it is definitely getting easier as I do it more.
Yay, that's what I
The
love to
tutoring,
hear.
like the tutoring center helps a lot.
Awesome. Very glad to hear that. All right, so let's see. You want to do 34, 35, or 36?
Let's try 34, I guess.
Okay. All right. So the key here is just to remember that we've got this format we've got to drop this into. And so to do that, we need to first write f of x plus h. So if we take, I'm going to try and do this all in one step this time instead of doing it in the 2 separate steps. I
Okay.
did this piece and then I put them together in this piece.
You
So if
were
we
just
do-
doing like the arithmetic part kind of fast, and I didn't get it all written down.
Oh, well, I'm going to send you these notes after we're done here too.
Yes, thank you
Yeah,
too. I
you're
appreciate
welcome.
that.
I feel you. I can't write it all down either.
It's a
Whenever
lot
a
to
new
write,
concept.
yes.
It is. All right. So if we look at f of x plus h, that means that for 34, we're going to say 32. And instead of x, we're going to say x plus h plus 12. So that's our f of x plus h piece. And then we're going to subtract from that f of x, which is 32x plus 12. And that all goes over h. So that's our f of x plus h on the left, our f of x on the right.
Okay.
And then we're going to distribute 32 to x plus h. So we get 32x plus 32h. 12 is trailing behind it. And then we're going to subtract from that f of x. So we're going to distribute that -1 to get negative 32x. And -1 times positive 12 gives us -12 all over h. And usually these are going to cancel out, and so that you don't have any terms remaining that don't have an h in them. And so if you look at 32x, that's going to cancel with -32x. If you look at 32h, it can't combine with anything. So that's our one that's going to stick around.
Okay.
And then we've got positive 12 and -12, so they're going to cancel out. And so we're going to simplify that and get 32 for an answer.
Okay, will it be 32 over h or just?
Just 32.
Oh, well, because the h will, okay, yeah.
Yeah.
Okay. So, yeah, thank you.
Sure. You want to see another one, or you want to look at something else?
Let's see. I'm looking at number 37 under here. It wants a linear function. Yeah, can we do 37, please?
Sure thing. And so if you're trying to find if a linear function could be used to model the data, the best thing to do is to look at the first differences and see if those first differences give you the same result. And so what that means is that we're going to zoom in on this data. We're going to say, okay, what's the difference between 585 and 615? Well, it's 30. Well, what about the next two outputs? What are the difference in those outputs? Well, 30.
Right.
And so when you
It's
see
like a constant.
And so whenever you see the output differs by a constant number, we would say that this is exactly linear.
Okay.
All right. And then if you look, if you were to get something like 30, 25, 35, then we could say maybe linear or approximately linear. And then if we got the difference of outputs that was just all over the place, then we would say, nope, not a line.
Okay.
But whenever we have this exactly linear increase, then yeah, we can model that with a line. And then if we want to write an equation of the linear function that fits the data, we could use our, there's different equations for lines. We could use, let's see, y minus y1 equals, where'd it go? There we go. I'm thinking of the point slope form here.
Oh, okay.
All right. And so we could use y minus y1 equals m x minus x1, but then we would also have to find the slope, but that's totally doable. So y minus y1 equals m x minus x1. And so we could say, you know, let's just pick on this first ordered set of data. And so we could say y minus 585 equals, we've got to find the slope, and then x minus x1, which would be 10. And then to find the slope, we would just take rise over run. Oops. And so we could take a second data set and we could say, okay, 615 minus 585, x2 is 20 minus 10. This is 30 over 10. So the slope is going to be 3.
Okay.
Okay. And then we say y minus 585 is equal to 3x minus 30. And then we could say y is equal to 3x. If I add 585 to both sides, that's going to give me 555. And that is your equation for the line.
Okay.
Snazzy, huh?
Yeah, I like that. That's helps a lot because that
Awesome.
confused me when I was looking at it.
Yeah, it can be intimidating. It's like, you gave me numbers. I don't know.
Let's see. I'm on down to chapter 2. I'm just
Okay, good.
looking here.
Yeah, I spent a lot of time on chapter 2. On page 36, students did not like, or wait, was 36? There's a section where you're solving literal equations.
On 36, 45 through 52, is that it?
No, let's see, 36. Let me look at my notes.
I definitely want to do one of those inequalities.
Okay. Why don't you just pick one and we'll do that? Yeah, because
Okay.
I'm not seeing the literal equations that they didn't like.
Okay. Can we do 51 there?
Sure. Awesome. Okay, so to solve 51, we're going to, the first thing we need to do is distribute that -3. So I'm going to say, let's see, we could go, yeah, I'm going to distribute it. So -3x, -3 times -5 gives me a +15. And that's less than -4. And then I'm going to subtract 15 from both sides. So I'm going to get -3x is less than -19. And then the trick here is that whenever you divide an inequality by a negative number, you have to flip the sign.
Okay.
So this would become x is greater than 19/3.
Okay. So I'll flip the sign for the fraction and the actual symbol. Like the fraction will no longer be -19 and negative.
Right, because you've got -19 over -3.
Okay. Yeah, that makes
Awesome.
sense.
Cool.
I haven't done these in a while, so, and I actually missed the last class because I had an appointment that ran over, so
Yeah,
I didn't get to do any of these in class.
gotcha. Do you want to see any others, or do you want to go? Let's see, we've got
Does our test go all the way to like 2.3? How far does it go?
through 2.4.
2.4, okay.
So let's see.
What about page 38? I bet that is the equations that you were talking about. It's a lot.
That is not them. Let me see. If you want to look and see if there are any you'd like to see solved,
Yeah.
I'll look for those equations. It was asking you to solve for one variable, and there was a whole bunch of variables. Yeah, and everybody was like, yeah, no.
That's the one we need. Okay. I probably need it too.
Feel you there. Oh, here it is. It's on page 40.
Okay.
Yeah, solve literal equations for a specified variable.
Oh my gosh, yeah, I don't like these.
What he does.
They're not fun, and Gavin in the tutoring center helped me so much with these.
Gavin is awesome.
He is. He's the one
I,
who taught me that fraction rule and then go ahead and multiply to get rid of them. He should be a teacher. He's great.
Yes, I agree. Gavin and Ben and I hung out in my office on a Sunday and did math for 2 hours yesterday, getting ready.
Oh
for
my
the
gosh.
session.
Yeah. Gavin is awesome. He was my CEC last semester too. He's really nice.
Awesome. Awesome. I'll have to tell him he's doing some good things. I'm hearing good things about him finally.
He is. He needs to stay around because I need him.
I'm telling you said that. All right.
Yeah,
You wanna-
I think probably on these though,
Uh-huh.
maybe number 45.
Okay. Solve P over 2 plus A equals 5M minus 2N for N. I like it. All right, so P over 2 plus A equals 5M minus 2N. And a lot of times I'll just highlight what I'm trying to solve for. And so the idea is to kind of peel this away like an onion. Everything they've done to that poor variable, we've got to undo it. All right.
Okay.
And so right now they're adding 5M to negative 2N. So I'm going to subtract 5M from both sides. So it gives me P over 2 plus A minus 5M equals negative 2N. And then to get N completely by itself, I need to divide both sides by negative 2. All right. And so when I do that, I get P over 2 divided by 2, negative 2. So this is going to be P over negative 4. A over negative 2 is going to give me A over 2, and I'm just going to pull that negative out front. And then negative 5M over negative 2 is going to give me positive 5 over 2M, and that equals N. Gross.
Yeah, that does not look very good. Okay.
Would you like another?
And so that's the final answer. Okay. It just
Yeah.
doesn't look very clean. So I never know when to, like, I guess when I don't know when to go any further is when I need to stop on these.
Yeah, whenever you've got the variable they asked for all by itself on one side, then you're done.
Okay. Okay. That helps a lot.
Yeah.
Let's see. I'm good at the Celsius ones under here. And the temperature. Oh, number 86. I'm horrible at those.
Okay, 86 on, yes.
40 on side
41.
41.
Yeah. Okay, the amount of heat produced in the human body by burning protein is directly proportional to the amount of protein burned. If burning 1 gram of protein, okay, so I'm going to start translating.
Yes.
So 1 gram of protein produces 32 calories of heat. How much protein should be burned to produce 180 calories?
Okay.
Okay, so where they're saying this is directly proportional, we can set this up to say 1 gram gives us 32 calories. And then we're going to solve for X grams to give us 180 calories.
Okay.
And then we can cross multiply and divide. So we say 1 gram times 180 calories is equal to 32 calories divided by X grams. We're solving for X grams. So I'm going to divide both sides by 32 calories. All right, so those 32 calories cancel out. So we get 180 divided by 32. And that's going to give us 5.625. So X is 5.625 grams.
Thank you.
Sure. And then you can actually go back and check your work on that, because if 1 gram gives you 32 calories, well, we know that 1 gram gives you 32 calories. Grams will cancel out. So if we multiply that answer by 32, we should get 180 back.
Yeah.
Awesome. All right, we've got 6 minutes left. What else would be helpful? Section 2.4 is usually pretty popular just because it's the last thing you learn.
Yeah. Okay.
Let's see. No, actually, I had more questions from 2.3 last time.
I'm looking at some of the questions to see which
Oh,
one
yeah.
I want.
Take your time.
Some of these are like graphing. I'm pretty good there. Okay, now that I'm in 2.4, could we do on slide 50, could we do number 16?
Absolutely. Okay. Solve graphically by the x-intercept method. Give the solution in interval notation. And so so we're going to set the left side equal to y1 and the right side equal to y2, and then you graph both of these in your calculator. And so we will say y1 is equal to -3 x minus 4. And then we would say y2 is equal to 2 times 3x minus 1. I would want to go ahead and clean that up. So -3 times x gives me -3x, and then -3 times -4 gives me +12. Y2 is equal to 6x. Let's see, 2 times -1 gives me -2. And once we graph those, we see that this has a negative slope. And so this one's going to be decreasing. This one has a positive slope that's it's double the other one. So at some point they're going to intersect. And wherever they intersect, that ordered pair would be the answer.
That's what it wants, is that value. Okay.
Yeah.
Okay, thank you.
Sure. Man, it's too bad more students didn't come hang out.
I know, I wasn't
tonight.
prepared to be on the spot like this and get to choose, because the last time I did one of these reviews, like they did one question I asked them to do. So this is like completely different.
I think there's just around 50 students taking 112A right now. So the final exam review is going to be the same way. I'll make a massive packet. I'll send it out a couple days ahead of time and be ready. It might be all for you again.
Hey, I love that. I'm totally happy with that. I think it's a lot better when you can ask more direct questions.
Yes, absolutely.
I think I'm pretty good for now. I'm
Awesome.
looking at some of the last questions
Mm-hmm.
At the very, very end.
Yeah. All right. Yeah.
And I think we already did some like these.
Mm-hmm.
Kind of like these.
Yeah.
So I think I'm good.
All right.
For
Fantastic.
now. I hope
Very
I am.
cool. All right. Well, I will email you and Mark a copy of the video as soon as it's done processing. And I will also email all of my chicken scratch so you can ponder over, what did she write?
Oh, I took notes too. So
all right.
I'll be able to decipher it for sure.
Fabulous. All right. Well, I wish you all the best tomorrow on your exam. And if you have any questions or trouble, just let me know. That's what I'm here for. Okay.
Thank you so much, Miss
Sure
Blue.
thing. Have a good evening.
You too. Bye-bye.